Last time we were talking about functions, particularly domain and range. Today we're going to talk about what sort of different types of functions we can have. And basically, the functions we're going to look at are going to fit into 4 families. So what I've got here is a list of functions. We've got 2x plus 1, we've got g of x is 1 over x, we've got x squared, we've got sine x, and then we've got a few weirder ones. We've got root x, and then the last two, x squared plus y squared, take 1 is equal to 0, and then x squared minus y squared is equal to 0. So what we're going to do is we're going to go through each of these, and we're going to sort of classify them into different families of functions, and then we'll talk about which ones we're going to be mainly dealing with the course. So this first one, 2x plus 1, I'm sure you can probably see that it's just a straight line. So what I've got here is I'm going to use GeoGebra today to have a look at the different functions. And this here is the function 2x plus 1. Now, we'll notice also that the domain is any real number, and also the range is any real number, so I can get any real number in and any real number out. But what I want to look at today is a way of classifying this function. And I'm going to classify it like this. For every value of x, for example, when x is 2, I get one value of y. So when x is 2, I get 2 times 2 is 4, and then I add 1, so I should get 5. So let's just have a look. Let's make sure we do. Scroll down. Just down a little bit. So when x is 2, I get 5. And when x is 0, I put 0 into the function and I get 1. And actually, for every single value of x, there is just one corresponding value of y. So a value of x is mapped to a single value of y. This is a one-to-one relation. So this type of function is called a one-to-one mapping. Okay, so let's go back and put that definition in. So this one here, this first function, is a one-to-one mapping. Or a one-to-one function. And basically what that means is each value of x is mapped to a single value in y. Okay. And this is a one-to-one relation. So this type of function is called a one-to-one mapping. Okay, so let's go back and put that definition in. So this one here, this first function, is a one-to-one mapping. Or a one-to-one function. And basically what that means is each value of x is mapped to a single value in y. Okay. So for every input, there's a corresponding output, and it's a one-to-one mapping. And the next graph, 1 over x, is exactly the same. It's a one-to-one mapping as well. So these are both one-to-one mappings. So they're both examples of one-to-one mappings. And let's go back to GeoGebra and see what that graph looks like. That graph is this one here. Okay, and let's come out a little bit. And you can see this graph 1 over x, although it's a little bit different to the straight line, you should be able to see that for every value of x that I put in, there is just one value of y that comes out. Okay, so when I put 2 in, I get a half out. And when I put -3 in, I get -1/3 out, because it's 1 over x. So every value of x that goes in has just one value of y that comes out. Okay, or one value of the function that comes out, I should say. So again, this one's a one-to-one mapping. Again, we can talk about the range and domain of this function. The domain, what values can we put in? Well, we can put in any value we want apart from 0, so x can't be 0. And what values can we get out? We can get out any value we want apart from 0, so the range is x cannot be 0 as well. But again, it's just a one-to-one mapping. Okay, let's have a look at this x squared graph. I'm sure you know what this graph looks like. So let's have a look. We'll get rid of those ones now, and we'll have a look at this x squared graph, which I think is this one. And it should be quite familiar to you. Now this graph is a little bit different because now, if I put, for example, the value of x where x is 1 in, I get a value of 1, so 1 squared is 1. But also if I put a value of negative 1 in for x, I get 1 out there as well. So in this case, every value of x doesn't correspond to just one value of y. There are multiple values of x that I can put in that give me the same value for the function out. For example, I can put 2 in, and I get 4 out. And I could put negative 2 in, and I also get 4 out. So this type of function is called a many-to-one function. Okay? There are lots of values of x. In this case, there's 2 values of x, which give me just 1 value of y. Okay? So this type of function is called a many-to-one function. And both of these functions are in fact many-to-one, so I'll put them like that. And we'll have a look at the sign one as well. So this is many-to-one. It's a many-to-one mapping. And let's define it like this. Multiple values of x are mapped to single values. X is 0, I get 0, and when x is pi, 3.14, I get 0, and when x is 2 pi, I get 0. Okay. So there's multiple values of x that give me the same value for the function output. Okay, and you can sort of tell when you draw a sketch whether a graph is one-to-one or many-to-one. You can see that it's many-to-one, that it will oscillate this way. There will be multiple values. I can draw a line horizontally, and it will, if it cuts more than once, then that means there's going to be multiple x values that give the same sort of height. Okay, so that's many-to-one functions. And basically, the type of functions we deal with on the course are going to be one-to-one functions or many-to-one functions. Okay, so let's just have a look at these weird ones at the bottom. We've got root x here, and root x. Let's have a look at it on GeoGebra first of all. Let's get rid of those two, and let's put in root x, which will be that one. And you can see this one's like a parabola, just like the x squared graph, except it's on its side now. And whereas on the x squared graph we had multiple values of x that gave us single values for the function, here if I go across and have a look at this graph, let's take for example when x equals 4, let's take when x equals 4, and I square root 4, I get two answers. I get 2 and negative 2. So this is kind of the opposite way around to the many-to-one graph, in that one value of x gives me many values of the function. So this sort of graph changes this way, and I have to draw a line vertically and see if it cuts twice. So, for example, again, if I took 1 when x equals 1 here, I get two outputs, 1 and negative 1. So this type of graph is called not a many-to-one graph, but this is called a one-to-many graph. This is a one-to-many mapping. And definition similarly, more one value of x gives multiple values for the function. It's I can bring the one over the other side so you see ones at the bottom. X squared plus y squared negative 1 equals 1, so it's a circle centred at the origin minus y squared equals 0. Well, the first one you might be able to spot is a circle. Just put that one in. Like that. And now you see I could take a value of x at 0.5 and it would give me an output for y up here and an output down here. So at 0.5 I would get a height, a certain height here and a certain height down here. And I would also get the same height for an x value of minus 0.5. I will get the same value of y's out for that. So there's two values of x that give me 4 values for y. So this type of graph is called a many-to-many function. And another example is the other one, which is essentially y squared equals x squared, where here I've got 1. When x equals 1, I get 1 and negative 1. And when x equals negative 1, I get 1 and negative 1. So there again, there's two values of x, give me 4 values for y. Okay? So this type of function is called a many-to-many function. So this is a many-to-many mapping. And again, multiple values of x give multiple values of y in this case. Okay, so they're the 4 sort of types of functions we're going to be looking at. But for the sake of this course, we are mainly dealing with one-to-one functions and many-to-one functions. Those are the types that we're going to be mainly dealing with. And in fact, if you come across a one-to-many mapping or a many-to-many mapping, then often we will just say that these type of functions, these last two types, we just call not a function. So we can save ourselves a bit of time. Rather than saying that these functions are one-to-many or many-to-many, we'll just call them, we'll just say they're not functions. And the only ones that are functions are these ones that are one-to-one mappings or many-to-one mappings.